Hi, grade 9. So today we're going to be doing lesson 6.2, which is called Lines of Best Fit. And there's a handout on Teams that you should print and fill in as you watch this video. So at the beginning of your handout, you see some terms that we're going to define to start with. So the first term is extrapolate. Extrapolate. And extrapolate means to predict a value by following a pattern beyond known values. So you're going past what you know. So a good way to remember this is to think extra, because you're extrapolate. So I'm just going to write that here. Think extra. The next term is interpolate. And interpolate means to estimate a value between two known values. So whereas extrapolating was going beyond what you know, interpolate means you estimate between some things that you already know. So a good way to remember this one would be to think in between. All right, and then a line of best fit is on a graph, on a scatter plot. It's a line that best describes the relationship between two variables in a scatter plot. And then you can find the equation of a line of best fit by using 2 points on the line to find the slope, and then insert a point, one of those points, into your equation to find b. In the equation y equals mx plus b. Your equation can be used for extrapolating or interpolating. Okay, let's do some examples to help this make more sense. So, number 1, Thomas is a member of the school track and field team. His times for running various distances are shown. So there's a chart there. Point A says plot the data on a scatter plot. So on the y-axis, you're going to plot the time in seconds, because in this case, the time depends on the distance, because he is not setting the time. Someone is saying, like the organizers are saying, okay, you run 50 meters and we'll time you. So now his time depends on his distance. And then distance is on the x-axis, and the distance is in meters. So just take a moment to plot those points. On the y-axis, there's room for you to go up by 2s. So you go 2, 4, 6, 8, etc. And on the x-axis, you can go up by 20s. So 20, 40, 60, 80, 100, 120, and so on. All right, so take a minute to fill those in. All right, so I'm going to plot 50, 6.1, a different color, 100, 12, 150, 18.3, 225.2, and 250 and 31.7. All right, so now you're going to take a ruler and we're going to draw a line of best fit. So a line of best fit goes through the middle of your data, and that doesn't mean it's going to go through all the points. That means that there's going to be about an even number of points on either side of it, but you need to make sure that you go through at least 2 points, okay? So I'll try to do it here, but I'm going to post my actual graph after I'm done this. So using a ruler, try to go through at least 2 points. Okay, so I'll just grab my picture for a second. Okay, so here's my graph from my paper actually, and you can see it's a little more accurate. So I went through the points 100, 12, and 200, 25.2. So our graphs aren't all going to be exactly the same because we can't graph perfectly because we're going to make mistakes. So as long as it's close, that's okay. Now go to the next page of your handout and we're going to answer some questions. So we now have our line of best fit, and question B says determine an equation for the line of best fit. So the 2 points that my line actually goes through, I have to use those 2 points. So those points were 100, 12, and 200, 25.2. So now I have 2 points. So I can find the equation of this line by first finding the slope. So slope is y2 minus y1 over x2 minus x1. So if I do 25.2 minus 12 divided by 200 minus 100, I'll be left with 13.2 over 100. 13.2 divided by 100 is 0.132. And that's my slope. So far in my equation, I have y equals 0.132x plus b. Now I need to find b. So I need to take one of these points. It has to be one of these because those are the only ones that I know for sure are on that line. So I'm going to choose 100, 12. So 12 equals 0.132 times 100 plus b. 12 equals 13.2 plus b. Now I need to subtract 13.2 from both sides to find b. 12 minus 13.2 equals b, and b is negative 1.2. So therefore my equation is y equals 0.132x minus 1.2. That's the equation of my line of best fit. So now letter C, that was B. Now letter C says, what is Thomas's time for a 175 meter run likely to be? So I'm going to use my equation here and I'm going to interpolate. So now I'm looking between the values. See how 175 is between 50 and 250, which were the numbers I plotted? Between 250. It's not way beyond them. It's in between them. So this is interpolating. And I need to find how long it took him to run 175 meters. So the x value here is the distance, so I'm going to put in 175 for x. So y equals 0.132 times 175 minus 1.2. And do that calculation on your calculator, and that equals 21.9 seconds. So it took him 21.9 seconds to run 175 meters. That's what we're estimating. That's his likely time. If you look at our chart that we got our information from, he ran 150 meters in 18.3 seconds, and he ran 200 meters in 25.2. So yeah, our number makes sense for his times. Okay, letter D. Is it reasonable to use the same line of best fit to determine the time needed to run 3,000 meters? Explain. Well, no, it's not reasonable because after he's running for 3,000 meters, he will be tired. So he won't be able to keep up the same pace as when he was running 100 meters, right? When you run 100 meters, you sprint, you run quickly. But when you're running 3,000 meters, you're slowing down, you're pacing yourself, all right? So let's say no, not reasonable because he will be tired. And E, what does the slope of the line of best fit tell you about how Thomas runs? So the slope is 0.132. That's his rate. So that means he is running 0.132 meters per second. All right? Okay. Number two. A chair company has a contract to build all 1,790 seats in a concert hall. The progress over the first week of work is shown in the table. So we have 7 days and how many chairs they have made altogether. So A, draw a scatter plot of the data. So on your x-axis, you're going to have the number of days. And on your y-axis, you're going to have the number of chairs completed. Then on the y-axis, you'll go up by 50. So 50, 100, 150, 200, 250, 300, and so on. And on the x-axis, you'll go up by half a day. So every other line will be a day. 1, 2, 3, 4, 5, 6, 7, and so on. All right, and then plot the points and then draw a line of best fit. So just take a minute to do that. And then I will post my graph once you've done that. So here's my graph. So I plotted all the points. Don't forget a title here. And then I drew a line of best fit. So remember, your line of best fit has to go through most of the points, as many as you can. For sure 2. And it has to be even. So try to keep a balanced number of points on either side of the line. All right, now we're going to use our graph to answer some questions. So we need to estimate the number of seats built after 9 days. How many are built by the middle of day 5? Well, we don't have 9 days on our graph. We have this 9 here, but it doesn't reach our line. So we're going to make an equation, and then we're going to extrapolate because we're going off to extra values that we don't know. So we're going to extrapolate. So we're going to create an equation, and then we're going to check how many seats are built after 9 days and after the middle of day 5. So 2 points that I took from my graph, which might be a little different from yours, and that's okay. 4, 443 and 6, 661. So I'm going to find my slope using y2 minus y1. So 661 minus 443 divided by x2 minus x1. And that leaves me with 218 over 2, which is 109. All right, so my slope is 109, so y equals 109x plus b. Now I'm going to insert one of these points into this equation to solve for b. So 661 equals 109 times 6 plus b. 661 equals 6 but 1 equals 654 plus b. B equals 661 minus 654. So that makes b 7. So my equation is y equals 109x plus 7. Okay, so now I have my equation. Now I can answer the question. So the question says, estimate the number of seats built after 9 days. So days was x, so 9 equals x. So y equals 109 times 9 plus 7. And that equals 988. So after 9 days, they've built 988 chairs. Now, how many are built by the middle of day 5? Well, the middle of day 5, we could say, is day 5.5, right? It's half of the day. So that's also x, so we'll insert that for x. Y equals 109 times 5.5 plus 7. And that is 606.5. So how many are built by the middle of day 5? Well, they're done 606 and a half, but they're not done that one yet. So just 606, right? C. Estimate the number of days needed to build 1,252 seats. So 1,252 seats is not x now because we're trying to find x. We're saying how many days. So our equation, we're going to put 1,252 in for y this time. So 1,252 equals 109x plus 7. Now we need to get x by itself, so we need to do the opposite of bed mass. So we're going to subtract first, take away the 7 from both sides. So 1,252 minus 7 is 1,245 equals 109x. And then 109 is multiplied by x, so we're going to divide by x. Divide by 109. 1,245 divided by 109 is 11.4. So the question said, how many number of days are needed? 11.4, so approximately 11 and a half days. Needed to build 1,252 seats. All right, and then letter D. The company gets a bonus if it's able to finish all of the seats in 2 weeks or less. If the workers continue to make chairs at about the same rate in the second week, will the company be able to collect the bonus? So 2 weeks equals 14 days. And we have to put it into days because that's what we're working with. If you put in 2, that will give you a wrong answer. So you need to put in 14 days. So going to our equation, let's plug in 14 and see if we get out 1,790 because they need to make 1,790 chairs. So it has to be 1,790 or more. So y equals 109x plus 7. Let's insert 14 and see if after 14 days they have made 1,790 chairs. 109 times 14 is 1,526 plus 7 is 1,533. So no, they have not made all the chairs in less than 2 weeks, so they will not be able to collect the bonus. All right, so that's your lesson. Now you have homework to do and to hand in, so let me know if you have any questions.